Hello and welcome to Excellent Link Academy. For this class, we'll consider the study of combination. So we'll look at the definition of combination, its mathematical expression, and also we'll look at the how to simply evaluate problems such as this, and finally look at the application of this combination and perhaps the algebra of combination. Let's look at this concept one after the other. By definition, combination can be defined as the selection or choosing of n different objects taking R at a time. So when it comes to combination, the key concept to watch out for is simply selection or choosing. So when the word selection or choosing, they're talking about combination. But when I hear the word arrangement, that's with what? Permutation. By the way, if you're interested in watching our full tutorial course on permutation, I'll drop the link to permutation in the description of this video. So try to watch some of this video. I'll drop a link to our permutation, right? In the description of this video. And also, or perhaps I can drop it above you here. Just click on the link above you here, take it to our full tutorial course on permutation. At this point now, note that combination is abbreviated by C. So we use C to abbreviate combination. So mathematically, note that combination n combination R is equal to n factorial all over n minus R factorial R factorial. Note that the mathematical expression for combination is given at n combination R, which is equal to n factorial over n minus R factorial R factorial. So at this point, note that the value of n is always greater than what? Greater than R. That becomes your mathematical expression for combination. All right, at this point now, we'll look at the relationship between permutation and combination. Let's look at relationship between combination and permutation. Let me put it this way. Right, so note that C represents combination while P represents permutation. Right, so note that let's look at relationship between combination and permutation. At this point now, recall that we said for permutation, n permutation R is equal to n factorial over n minus R factorial. This man here is the mathematical expression for what? Permutation, right? Similarly, observe something please. For combination, now we said combination, that is n combination R is equal to n factorial over n minus R factorial R factorial. So what's now the relationship? Look up, here's the relationship, please. Observe that here to this point here is what I'm saying here. Observe. Look at it. From here like this to this point here is what I'm seeing here. So replace everything here by what? By this. So that becomes, I can express n combination R now as being equal to what? N permutation R all over R factorial. So this R factorial comes down here. Everything here is simply what is here, and the value is what? N permutation R. So I have this. So this becomes what? Your relationship between permutation and combination. So it becomes your relationship between permutation and combination. All right, at this point now, let's move to how to evaluate problems under combination. So let's start with number one there, solution. Let's start number one. Number one says 8 combination 3. How do you possibly evaluate this? It's quite simple. Follow the same pattern of your mathematical expression. You said n factorial becomes your n here, that's 8. That becomes your 8 factorial all over, this is n minus r, that becomes 8 minus 3, 8 minus 3 factorial, then what, 3 factorial. At this point, what do you get? That becomes 8 factorial all over 8 minus 3 is of course 6. 6 factorial, 3 factorial, right? So last class, when we discussed about permutation, we look at the concept of factorial last class. So by the way, if you want to understand the idea of factorial, which our previous class on permutation, I explained the concept of factorial from crash, right? So from here now, I can say that, sorry, this is 5, please. 5. 8 minus 3 is 5 now, 5. From here now, I can expand 8 factorial as being equal to 8 times 7 times what? 6 times 5 factorial all over 5 factorial times 3 factorial. This one cancel this. So I'm left with what? 8 times 7 times 6. All over what there? 6. 3 factorial is about 6. So multiply together. What do I get? From here now, 8 times 7 times 6. That's 336. 336 divided by 6. What do we get? I have, my answer becomes 56 as my answer after solving this particular problem. Let's look at, you do number 2 for me, right? So let's do number 3. Third one there, C. For C, I have 15 combination 11 minus 11 combination 9 plus 5 combination 5. Sorry, 9 combination 5. Let's look at how we can possibly evaluate this. To evaluate this is a quite easy task. The same procedure, but in this case here, I'll not go too lengthy this way. I want to show you can possibly get this value in calculator without stress. So I'll take my calculator and punch 15 combination 11 straightforward. What do I get? Observe please. I'll punch 15. 15. This is my 15 here, right? 15. Then shift. Look at combination here. Combination is under this place. Combination. Observe combination 11. So I have about 1365. So I have 1365 minus. I'll punch 11 combination 9. That will give about 55 plus 9 combination 5. 9 combination 5, that's 126. If I simplify this, what do I get? So I get 1365 minus 55 plus 126. I have 1436 as my answer. So observe, depending on how you are fast and smart. So instead of me going this way, I can use my calculator to get a value quickly and faster. So it becomes your task behind this particular problem. At this point now, let's look at the concept of algebra of combination. Let's look at the algebra of let's look at the algebra of combination. When it comes to the study of the algebra of combination, we'll be looking at how to find the value of n, right? Look at how to find the value of n. So let's look at some of the example you can actually use to find value of n here. So example says that find the value of n in the following. Find the value of n in the following. N combination 2 equal to 15. B, I have n combination 3 equal to 15. Sorry, 35. C, I have n combination 2 equal to 2n combination 4. Right? Let's look at D. For D, they have n combination n minus 4 equal to 15. And then E, I have 20 combination r plus 11 equal to 20 combination 3r plus 1. Let's try to solve this particular problem here, and let's see what we get. So it becomes your idea behind algebra. You'll be told to look find for n. So I said that the question says that find the value of n in the following. So I have the following here. So let's look at how we can solve this particular problem individually. For number one, I'll still apply the same technique we used for permutation in our last class, right? So how do we solve that? For number one there, for A, I have n combination 2 equal to what? 15. It's simple. What's your expression here? This becomes n factorial over n minus 2 factorial 2 factorial is being equal to what? 15. I have this. What's your next task? I'll expand n factorial in terms of what? N minus 2 factorial. So, but we said in last class, but n factorial equal to what? N into n minus 1, n minus 2 factorial. Don't ask me why. Watch our previous class on permutation. You should know this, right? So I'll replace n factorial as what? As this here. That becomes n into n minus 1, n minus 2 factorial, all over there, n minus 2 factorial 2 factorial equal to what? 15. What do you observe? This man will cancel this. I'm left with what? N into n minus 1 over what? Over 2 factorial equal to 15 over invisible 1. So what? Cross multiply. I'll have n into n minus 1 equal to what? 15 times 2 factorial. Of course, 2 factorial is still 2. So I'll have n into n minus 1 equal to what? 15 times 2. Alright. At this point now, how do we get our value for n here? So proceeding with the solving, let's see what we get. So proceeding, let's see what we get. From here now, I'll have n into n minus 1 equal to what? 15 times 2. That's about 30. So listen up, I'm having 2n, n and n, 2n. So look for two numbers such that if you multiply them together, you have 30. And if you minus them from each other, you have 1. So that becomes n into n minus 1 equal to 6 times 5 is 30. 6 minus 5 is 1. So that becomes what I'll use here. So I'll pick this n to be equal to this 6 here. Or I'll pick n minus 1 to be equal to what? This 5 here. So n equal to what? 5 plus 1. When this 1 minus 1 come, it becomes plus 1. So n is what? 6. So my value for my n there is 6. So therefore, n equal to 6. That becomes your answer for question A. You do question B, right? I'll do question C now. Or perhaps, okay, let's work together, please. Let's do B. I have n combination 3 equal to 35. The same technique applies here. This gives n factorial over n minus 3 factorial 3 factorial equal to 35. How do you solve this? It's simple. Expand this in terms of this. N into n minus 1, n minus 2, n minus 3 factorial. All over what there? N minus 3 factorial 3 factorial. I explained why this n factorial exists in our previous class, right? Equal to 35. So this one cancel this here. I'm having n into n minus 1, n minus 2, right? Over 3 factorial, 3 factorial. So equal to what? 35. So what all I do at this point are what? Cross multiply. So what do I get? So from there I'll cross multiply and so we'll get. So from there I'll have my value as being n into n minus 1, n minus 2, right? All of, sorry, okay, is equal to what? 35 times what? 3 factorial is of course 6. So I have n into n minus 1, n minus 2 equal to 35 times 6. We give about 35 times 6. I'll have 2110. Sorry, 210. I have 210, right? So what does it mean? I'm having how many n here? 3 value of n. I'm having n. So I'll look for 3 numbers that I multiply them together. If I multiply them, I'll have 210. If I add the, if I subtract them from each other, I'll have 1. So that becomes 7 times 6 times 5. So that becomes n into n minus 1, n minus 2 equal to 7 times 6 times 5. 7 minus 6 is 1. 6 minus 5 is still 1. So these are the value there. So I will equate this n to be equal to what? This 7 first. So my n is 7. Or pick out this one. N minus 1 equal to what? This 6. Or pick out this one. N minus 2 equal to what? 5. So from here now, what do I get from here? So from here, what do I get? I'll have n equal to 7 or n equal to what? Sorry, this is 1 now. Or n equal to what? 6 plus 1. This one coming just 6 plus 1. N is still 7. Or n equal to what? 5 plus 2. N is still 7. So therefore, n equal to what? 7. So my n there is 7. Let's look at these other problems here. Let's do problem C. Let's do problem C. For problem C there, the task is quite simple too, right? So let's see what we get. All right, let's do number 3. So it becomes, some gives n factorial over n minus 2 factorial 2 factorial is equal to 2 dot, or perhaps 2 times n factorial over n minus 4 factorial 4 factorial. So I have this one here. So I have this. What's the next task? Expand this one. N into n minus 1, n minus 2 factorial over what there? N minus 2 factorial 2 factorial is equal to 2 times, expand this one, n into n minus 1, n minus 2, n minus 3, n minus 4 factorial all over n minus 4 factorial 4 factorial. What do you observe? This one here cancel this. This one here cancel this one. What are we left with? What are we left with? All right. From there now, I'll be having n into n minus 1 over 2 factorial, this one and this there, all right, is equal to 2 times n into n minus 1, n minus 2, n minus 3, all over what there? 4 factorial. Observe that I'm having, whenever we have last class on permutation, whenever we have two things in the equality sign, it's cancel out. What do I mean? If I have AB equal to what? AC. A can cancel out A. They are the same thing, right? So what I mean here, this one will cancel this one. So I'm having what? 1 over 2 factorial equal to what? 2 into n minus 2 into n minus 3 over what there? 4 factorial, right? So my task now is quite simple, right? So I'll have 1 over 2 equal to 2 into n minus 2, n minus 3 over 24. So 4 factorial is 24, right? So I have this. So they observe 2 here 1, 2 here is 12. So I have 1 over 2 equal to n into n minus 2, n minus 3 over 12. Over 12. So from here, what do you observe? I'll simply what there? If I want to, I can expand this bracket here. So I'll have, okay, first, let's expand through. So 12 times 1 is 12, right? Equal to 2 into n minus 2, n minus 3. So I have this. So I'll multiply. 1 times 12 is 12. 2 times everything here, that I have here. It becomes, look up please, it becomes, the next task now is to divide by 12 by 2. So I want 2. Divide here by 2, divide by 2. This cancel this, Abby. So I have what? 12 over 2 is 6. All right. 12 over 2 is 6. So I have 6 here being equal to everything here, n into n minus 1, sorry, n minus 2, n minus 3. Right. The n that is here should not be here. So what I get from here? So these are 2n. So I'll break 6 down. 3 times 2 will give 6. N minus 2, n minus 3. So pick out this one, n minus 2 equal to 3, or pick out n minus 3 equal to 2. This gives n equal to 3 plus 2, n is 5, or n minus n equal to what? 3, sorry, 2 plus 3, n is still 5. So my value for n here is 5. It becomes how to solve this particular problem. So next class we'll look at the concept of application of combination. See you in the next class.